Back now with that massive sinkhole wreaking havoc in Florida over the weekend.
A sinkhole with a deadly history is reopened.
Well, tonight's third top story could also be dangerous, so stay away.
A chilling revelation has emerged from beneath the Atlantic waters off Florida's coast. The United States Geological Survey, USGS, has just issued a red alert following the discovery of a startling geological anomaly on the ocean floor. This discovery isn't just a scientific footnote. It's a potential game changer with vast geological, ecological, and societal implications. The event centers on an area of the seafloor that has, until recently, drawn little attention from the general public, though geologists have quietly monitored it for decades. What they've now uncovered is causing shockwaves across the scientific community and beyond. Before we start, smash the like and subscribe buttons for more updates. The discovery came during a deep-sea mapping mission involving a collaboration between the USGS and NOAA, using cutting-edge sonar and submersible drone technology. While scanning a known fracture zone near the Straits of Florida, scientists observed unusual seismic patterns and heat signatures that prompted a more focused investigation. What they found was a dramatic and unexpected rise in hydrothermal activity, combined with a rapid uplift of the ocean floor in a concentrated area, phenomena typically associated with tectonic instability and magmatic intrusion. This is not something that can be easily dismissed as a routine geologic event. The area of concern lies in a segment of the seabed thought to be relatively dormant. Known for its carbonate sediment layers and calm structural behavior, this part of the ocean floor has rarely shown any signs of the type of geologic unrest now being detected. But the latest readings paint a very different picture. Cracks are appearing in long-established carbonate platforms, some extending for miles, accompanied by measurable shifts in the seafloor elevation. Subsurface imaging has revealed magma pushing up toward the crust, exerting pressure and generating localized heat zones far greater than anything previously recorded in this region. As data streamed in, the urgency escalated. Chemical sensors deployed by autonomous submersibles recorded an anomalously high concentration of methane and other hydrothermal vent gases, usually only seen in active volcanic regions. Furthermore, acoustic mapping detected patterns resembling harmonic tremor, a seismic signal often linked to volcanic activity where magma is moving through subterranean conduits. This signal alone was enough to elevate concern, but when paired with the thermal anomalies and the methane surges, it signaled something even more pressing. A deep earth process is actively reshaping Florida's underwater geology. The implications are profound. Florida, a state largely built on porous limestone and vulnerable to even minor shifts in sea level, could face existential threats if this seafloor unrest continues to grow. Any large-scale deformation of the ocean floor has the potential to displace vast volumes of water, potentially triggering underwater landslides or even tsunamis. A massive underwater landslide, while rare, has precedent in other parts of the world and has previously caused waves reaching coastlines within minutes. The proximity of the anomalous zone to heavily populated coastal areas such as Miami, Fort Lauderdale, and the Florida Keys only intensifies the stakes. One of the more disturbing aspects of the USGS findings is the suggestion that this is not an isolated incident, but part of a broader geological awakening. Data comparisons with past readings show a gradual increase in tectonic stress over the last 5 years. Subtle enough to go unnoticed until now, but clear in hindsight. The red alert designation is not simply precautionary. It reflects a confluence of risk factors: the rise in magmatic pressure, the structural weakness in the surrounding crust, and the chemical signs of a possible eruption scenario deep beneath the seabed. While no eruption has occurred, and there is currently no open vent on the ocean floor, the presence of rising magma itself is a serious concern. Subaqueous volcanic systems are capable of remaining hidden for long periods, their activity masked by the ocean's depth and pressure. However, once a critical threshold is crossed, they can erupt with immense force, releasing not only lava, but also massive quantities of gas and energy that can destabilize entire sections of seabed. In Florida's case, such an event could be catastrophic. Adding another layer of complexity is the discovery of unusual biological activity in the area. Scientists aboard the research vessel observed rapid changes in microbial populations near the seafloor vents. These extremophiles are known to thrive in hot, chemically rich environments, and their sudden bloom is a biological marker of increasing geothermal energy. This rapid biological response to geologic changes has often been an early warning sign in other parts of the world, such as in the Pacific Ring of Fire, where undersea volcanic eruptions are more common. The ecological chain reactions that follow such blooms can also affect commercial fisheries and coastal marine life, adding another dimension of risk. The seabed's elevation increase recorded via satellite altimetry and underwater GPS systems confirms that pressure is building at depth. In some areas, the upward shift has been as much as 8 centimeters in a matter of weeks, an extraordinary rate when viewed through the lens of geological time. To put this into perspective, seafloor uplift at known active volcanic sites like the Canary Islands or the Azores typically occurs at rates of a few millimeters per year. The rate of change off Florida's coast is far more aggressive, and it's this acceleration that alarms scientists the most. One hypothesis gaining traction among geologists is that a previously undocumented magmatic system is awakening beneath the Atlantic, just east of Florida. While not connected to a traditional plate boundary, the region may harbor an ancient rift or fracture zone capable of reactivation. Similar zones exist worldwide, often becoming sites of volcanic activity after remaining dormant for millions of years. If this is the case, then Florida could be dealing with a slow-developing but powerful natural system operating far outside the realm of normal tectonic expectations for the eastern United States. Another implication of this discovery is the potential impact on Florida's freshwater aquifers. The state's porous bedrock, which holds vast reserves of drinking water, is directly linked to geological stability. If the seafloor disturbance leads to increased subsurface pressure or seismicity on shore, it could cause fractures or shifts in these freshwater systems. Salinization of freshwater supplies is already a concern due to rising sea levels. A sudden geological disruption could hasten that process dramatically. With millions relying on these aquifers, this represents a silent but significant threat. Insurance companies and infrastructure planners are also watching the situation closely. Florida's coastal cities are heavily developed, with billions of dollars in real estate sitting at or near sea level. Any geophysical activity capable of altering the coastline or inducing even a minor tsunami could have devastating economic repercussions. The red alert status acts as a warning not only to scientists, but also to emergency planners, insurers, and local governments, all of whom must now reconsider risk models and preparedness strategies in light of this unfolding scenario. Interestingly, the tectonic unrest isn't confined to one narrow region. Further scans are revealing that the anomaly extends in a semi-linear path running from the southeastern edge of the Florida platform down toward the northern coast of Cuba. This alignment matches with several older, dormant fault systems previously thought to be geologically irrelevant. However, if reactivated, these faults could form conduits for deeper magmatic movement, expanding the threat zone well beyond Florida's borders. A seismic awakening in this corridor could place parts of the Caribbean, including the Bahamas and northern Cuba, at similar risk. In a deeper layer of analysis, scientists are also considering the possibility that the anomaly could be connected to a mantle plume, a column of hot rock rising from deep within the Earth. While mantle plumes are typically associated with island chains like Hawaii, recent studies suggest they can exist in more subtle forms elsewhere. If such a plume is emerging beneath the Atlantic, it may represent a long-term reshaping of the region's geological architecture. Over geological timescales, mantle plumes create volcanic islands, uplift continental shelves, and even contribute to the formation of new ocean basins. While such transformations take millions of years, their early stages can still produce hazardous conditions in the present day. As the research continues, seismic sensors along the ocean floor are being expanded in both range and sensitivity. Satellite data is being fed into supercomputers to model worst-case scenarios, including seafloor collapse, gas release, and pressure-induced tsunami formation. The goal is to anticipate the chain reactions that could occur if the pressure underground is suddenly released. Even if the region avoids a volcanic eruption, the risk of a hydrothermal explosion or a gas blowout remains high. Both events can trigger violent disruptions of the water column, and under certain conditions, generate surface-level waves powerful enough to reach land. The red alert also has implications for marine navigation and shipping lanes. The Straits of Florida are a critical commercial passage, used by cargo ships, cruise liners, and fishing fleets alike. An undersea event here could disrupt global supply chains, reroute marine traffic, and potentially damage undersea communication cables. These cables, which carry internet and communication signals across continents, are vulnerable to seismic displacement and thermal damage. A single rupture could interrupt connectivity for millions. All of this unfolds against the backdrop of climate uncertainty. With rising sea levels, intensifying hurricanes, and now a newly active geological threat, Florida is facing a convergence of environmental stressors unlike anything in its history. The ocean floor, once seen as a passive neighbor, is revealing itself to be far more dynamic and unpredictable. The red alert isn't just a technical classification, it's a signal to scientists, governments, and citizens alike that our understanding of the region's stability is being fundamentally challenged. The scale of the anomaly also raises philosophical questions about humanity's relationship with the Earth. For all our technological advances, the deep ocean remains one of the least understood environments on the planet. This recent discovery off Florida's coast underscores how much remains hidden beneath the waves and how quickly the natural world can shift from silent to volatile. Even now, scientists aboard research vessels continue to send submersibles into the depths, probing fissures, sampling gases, and scanning the terrain for signs of what may come next. One thing is certain, the ocean floor is changing, and with it, the assumptions long held about Florida's geological safety. The red alert issued by the USGS is not a prediction of doom, but a recognition of risk, the kind that demands vigilance, research, and preparedness. As the data continues to pour in, the world watches, waiting to see what revelations the Earth will yield next from its watery depths. The underwater landscape off Florida's coast has shifted in both literal and metaphorical terms. As scientists delve deeper into the anomaly that triggered the USGS red alert, a new dimension of complexity begins to unfold, one that stretches far beyond the traditional frameworks of marine geology or regional risk assessment. What's emerging is a picture of dynamic subterranean forces in transition, a tectonic puzzle that could redefine much of what is currently understood about the stability of the southeastern United States and its underwater margins. In recent weeks, oceanographic teams have intensified their study of the affected zone. What they're finding isn't a simple volcanic bulge or linear fault displacement, but rather a mosaic of fractured crust, thermal plumes, and deep fissures filled with unusually dense mineral deposits. High-resolution magnetic mapping has revealed chaotic shifts in the Earth's magnetic field directly above the active zone, suggesting not just thermal flux, but also changes in the rock composition beneath the crust. This indicates a deeper and more turbulent interaction between the Earth's mantle and crust in this region than previously acknowledged. One of the more provocative discoveries came from deep core samples taken from recently opened fissures. The samples included rare earth minerals and crystalline structures typically found only in active magmatic environments. Some of the mineralogical formations are not only rare but previously undocumented in the Atlantic basin. This is leading some researchers to consider that they may be witnessing the early formation of a new underwater volcanic province, a complex of potential vents and magma conduits rather than a single eruptive source. Further complicating matters is the detection of piezomagnetic anomalies, subtle changes in magnetism related to the buildup of mechanical stress in rocks. These signatures often precede seismic events or indicate slow but powerful deformations occurring deep within the crust. Instruments anchored to the ocean floor have picked up measurable shifts in magnetic intensity over the past several weeks, signaling not just structural tension but also the potential for sudden releases of stored energy through tectonic motion or hydrothermal bursts. The environmental indicators are equally unsettling. Plankton samples retrieved from nearby water columns show evidence of biochemical stress, such as malformed cell walls and altered reproductive cycles. These changes are believed to result from both elevated temperatures and a spike in deep-sea mineral influx. Elements like manganese, iron, and sulfur, typically expelled from hydrothermal vents, are being found in concentrations nearly double the usual range. This suggests a steady seep of subterranean materials into the upper ocean layers, affecting the delicate balance of the marine ecosystem in a region already vulnerable to climate stress. commercial fisheries along Florida's eastern seaboard have also begun reporting unusual catch patterns. Deepwater species are migrating into shallower waters, while others are appearing in locations they haven't been seen in decades. This disruption, while seemingly a minor shift in marine behavior, aligns with known effects of submarine thermal activity. Subtle changes in water chemistry and temperature can throw off food chains, migration routes, and reproductive cycles, potentially crippling local economies that rely on consistent harvests. Meanwhile, the Florida shelf itself, the massive underwater platform that borders the state, is now under renewed scrutiny. Previously regarded as a stable feature formed largely by sedimentary buildup and coral development over millions of years, parts of this shelf are now displaying microfracturing and subsidence in key sections. Submersible robots have captured footage of slowly widening fissures and gas bubbling from cracks in the seafloor. While not dramatic to the naked eye, these are early symptoms of geological instability that could evolve over months or years into more pronounced collapses or shifts. Hydrologists and geophysicists have also turned their focus inland. The concern is that the offshore seismic and magmatic disturbances may be influencing subterranean stress patterns in Florida's peninsula itself. Florida lacks major fault lines, but the entire state sits atop a platform of karst limestone riddled with underground rivers and sinkhole-prone cavities. Any increase in subterranean stress, even from offshore origins, could ripple through these porous rock layers, leading to the spontaneous formation of sinkholes or the collapse of already fragile ground structures. Early-stage tremors have already been recorded as far inland as Gainesville and Ocala, far outside typical seismic zones. With the intensity of observation increasing, drone-operated ROVs, remotely operated vehicles, have been deployed in shifts around the clock, scanning the seafloor in overlapping grid patterns. These ROVs are equipped with thermal cameras, pressure gauges, chemical sensors, and magnetometers, all working to assemble a real-time 3D model of the evolving zone. The hope is to identify patterns or thresholds that could signal a pending escalation, whether in the form of a submarine landslide, an underwater eruption, or a series of shallow quakes. Another avenue of concern comes from the rising levels of carbon dioxide and hydrogen sulfide being released into the water from the ocean floor. These gases, when dissolved in large quantities, can alter ocean pH and affect marine respiration. In certain geological events, like limnic eruptions, trapped gases beneath bodies of water can be released explosively, suffocating marine and even terrestrial life. While this specific outcome is unlikely in open ocean conditions, the increase in gas venting still marks a hazardous trend. Any further spike could pose a hazard to divers, submariners, or undersea infrastructure. Speaking of infrastructure, one of the lesser discussed vulnerabilities is the vast network of undersea cables that crisscross the Atlantic and connect Florida to the broader world. These fiber optic lines are buried beneath the seafloor and are critical to everything from banking transactions to national security. If tectonic movement or magma-related pressure deforms the seabed, it could shear or melt these cables, effectively severing digital communication for thousands of miles. Repairing these cables is costly and slow, often requiring deep-sea missions that can't proceed safely in tectonically unstable zones. Another frontier being actively investigated is the thermal dynamic of the ocean layer directly above the disturbance. The sudden injection of heat into the lower ocean can have strange and cascading effects on weather systems. There's concern that the geothermal plume could create thermal anomalies at the surface, potentially feeding into tropical storm formation or altering hurricane paths. While speculative, early climate simulations show that even modest thermal disruptions in the Atlantic can modulate the jet stream, wind shear, and barometric pressure, all key variables in storm development and trajectory. In broader geopolitical terms, the red alert has drawn international attention. Governments in the Caribbean, Central America, and even Europe are now monitoring the situation closely, as any significant geological event in the Atlantic has the potential to send tsunamis rippling across the ocean basin. The Bahamas, lying just northeast of the anomaly, is in a particularly precarious position. With low-lying islands and fragile infrastructure, even a moderate displacement of water could have devastating consequences. The Cuban government has also issued internal advisories to its coastal provinces, and international scientific bodies are preparing joint monitoring frameworks to share data as the situation develops. Perhaps one of the more intriguing long-term considerations is the possibility of this event opening up new scientific pathways for understanding plate tectonics in the Atlantic. The Atlantic Ocean is not known for its subduction zones, areas where one tectonic plate dives beneath another. But some geologists are revisiting that assumption. They theorize that what's occurring near Florida could be a precursor to a rare reverse subduction process, or even the embryonic formation of a new tectonic boundary. This idea challenges decades of geological orthodoxy and could shift the focus of research toward previously overlooked features of the North American plate's eastern boundary. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the USGS red alert issued for Florida's ocean floor? We want to hear from you. Thank you for watching, and see you next time.